If we talk about DED additive specifically, we know this involves multiple heating and cooling cycles as we build up the parts. What specific challenges does this pose?
Yes, Lyle. So when we have these multiple cycles we have in DED additive manufacturing, what we see is that the cycles, in contrast to welding, they can vary significantly. And they can vary because as we build our component, the shape is changing, so the geometry over which the material is cooling is different. And also, there's a phenomenon that we get to see in this animation here and in the graphs on the left, in the schematics of the left, how heat accumulates, right? So that means that if we have the same current and voltage or whatever process parameters being the same, the metallurgical effect is going to be different. That is a significant contrast with welding. And these different metallurgical effects result in different microstructure and material properties. And if we have perturbations or inconsistency, they can be magnified. And something in particular to care about in materials like carbon steels is when we reheat in a previously existing heat affected zone, right? After we weld, the area next to the weld is affected by the heat. That's what we call the heat affected zone. We have a schematic there. And when we reheat that, in some materials, that can be a significant challenge. And if we don't know the cooling rate at which that is happening or the extent to which the heat affected zone reaches, we can find problems that were unexpected.